Thank you very much. I'm excited. This is the first Walks days of the year, so thank you, Federico, and rest of the Walks Zurich team. I'm excited. This is my first Walks Zurich. My name is Arun Gupta. I work for Amazon. Particularly, I work in the open source team at Amazon, and I work with different service teams across Amazon to help define their open source strategy. I am also the Cloud Native Computing Foundation board member from Amazon. So work very actively with our containers team, particularly the EKS, ECS, and the Fargate teams. And I live and breathe Kubernetes every day, pretty much. And I spin up a cluster, tear down a cluster, play with it, or do something around it. And I'm also a Java champion. So I was part of the JDK team back in the Sundays, in 1.1, I think 1.2 is what we were releasing. And I'm one of the founding members of Java IDE teams. A lot of Java background history that I have. Now, this is a topic that is something close to my heart. As a Java developer, when I'm starting my journey to containerize it, what is it that I need to be aware of? I want to Kubernetesize, so to say, my application. What is it that I should be aware of? What is it that I should do? So there are no slides here. It's a GitHub-driven presentation, essentially. So the way I'm looking at it is, this is the code that I've written. And in terms of the presentation flow, we'll talk about the basic application, what my application is. We all know either a micro-profile application or a Spring Boot application or some sort of that. So I'm going to show you my basic application there. Then we'll talk about it. Okay, what are the tools and how I'm building that application? Either using Gradle or Maven or hopefully not Ant, but whatever it is. But then I'll talk about how do I bring those tools, and in order to go to Kubernetes, you need a container. And the container format is Docker. So how do I Dockerize my application using my build tools? I don't want to learn a new tool chain at all if I can avoid it. Then we'll talk about some of those. One of the big things about a JDK is, with JDK 8, at least there is a JRE that ships with it. With JDK 11, there is no JRE that ships with it. So what you can do is you can create your custom JRE very easily, which really gives you a lean Docker image, particularly very relevant in the microservices space, as your images are being downloaded across the internet, as they are being provisioned on different hosts. So we'll talk a little bit about that. I'm used to IntelliJ, NetBeans, Eclipse, those kind of tools. So how do I edit my Docker applications or Kubernetes applications using those standard set of tools? And then eventually, once my application is ready, I've written a Docker file, I've created a Kubernetes manifest. Now I want to test this application on my local machine. How do I start with that? And then eventually take that application to the cloud for production. And then finally, now that the application is running, what does my journey look like? How do I monitor that application? How do I build a deployment pipeline? How do I monitor that application? Do I canary testing or A/B releases and all sorts of stuff, fun stuff that I can do? Okay, so there's a lot to be covered in this particular talk. This could be really a 3-hour tutorial if you were to look at it. And as a matter of fact, I just released a course on LinkedIn Learning. So if you are on LinkedIn Learning, take a look at that course. It's about 2.5-hour long course that goes into full detail of all of this. But the GitHub repo is, of course, open source. So all the samples are here. Okay. So first thing first, and I'm purely going to drive it through GitHub here and hoping the internet will participate here. So first thing first, I'm going to take a Spring Boot application. Okay, so go here. Here is my app. And in my app, I got source main, package, etc. I got a simple application controller or greeting controller. It's just a simple REST endpoint. You ping it at /hello. It returns a response back. Hello. That's it. So I don't want to purposely choose a complex application because the focus is not how to teach you Java applications. You are excellent developers, you know how to build Java applications. I want to show you the hook points that allows you to build your application and then connect it to the Kubernetes world. So now we go back here. Now if I look at sort of my pom.xml, pom.xml is very standard, nothing fancy here. Spring Framework parent. I got my starter here. And then I Spring Boot Maven plugins. It allows me to run my application very easily and then get started with it. Now in here I have a profile, which we'll talk a little bit later, but essentially the idea is if I run my application now, I will get I run my applications literally as Maven Spring Boot :run. It fires up my application and then I can curl it. So let's take a look at that, how I'm going to do that. Okay, so I'm going to go to app here. I'm going to say Maven Spring Boot :run. Okay, so that's going to package up my application. It's going to deploy my application, run up my application. All that application runs up, and then I go to a different tab here and I say curl HTTP localhost :8080/hello, and I get a hello response back. So that's my starting point. You know, it's a simple Spring Boot application returning a hello response back. So let's go back here and terminate my app here. Okay, Control C and done with it. I've been researching a running watch, so. Okay, so the next step really is now, how do I create a Docker image out of it? Multiple ways by which you can create Docker image. Well, of course, you can write a Docker file, but writing Docker file could be hard. There is even a section dedicated on docs.docker.com, which talks about exactly what are the best practices around Docker file. To me, best practices feel like, ooh, I don't think we did a good job of building that tool. Let me write you what the bugs are and how you can get around those bugs. And these are my best practices. So writing Docker file could be really hard, making sure that what is my base image, that I'm using the copy statement, not the add statement, what port should I expose and things like that. Okay. But a lot of customers, love Dockerfile and they write it. So that's one option, of course. So what we can do is, now, if you understand how Docker images are created, they're nothing but a bunch of layers. And every time you change anything in the layer, the whole image gets recreated, or that particular layer gets recreated. Now, in case of Maven, if any dependency changes, the whole Maven gets downloaded on your machine, and that whole layer gets changed. So that's a big fat layer right there itself. So to simplify that, what I've done is, in this case, for example, I create a local M2 repo, mttor.gz. So I said, you know what, put everything in my local directory here. I'm going to tar it up. And once I tar it up, then I'm going to create my Docker image. Okay. And how I'm going to do that? So let me open up a new tab here. And if I go to app and I look at my Docker file here. So in this Docker file, I've created m2tar.gz already, and I put that into my root of my container. Now the basic here I'm using is Maven 3.5 JDK 8. So what I'm using is Maven 3.5 as my base image, and then I'm saying take that as my m2tar.gz. So that with every run, I don't want you to download the Maven repository into the internet or into my Docker image. So that keeps my Docker file lean. So that's one part of it. Now I'm copying my source code from the current directory to user source app. Then I say Maven batch mode, refer to that pom.xml clean package. So that's one part of it. Now this Docker file particularly is a multi-stage Docker file. Usually in a Docker file, you will have a single from statement. In this case, I got two from statements. And what that means is each from statement is a new stage. So my first stage here is on line 1 and is labeled as build. The second stage here is using an OpenJDK 8.8 JRE image. One of the strong design patterns that I've seen in customers is they use JDK to bundle with their entire application, even though they may need only JRE. Don't do that. You don't need to do that. Particularly if you're using JDK 8, it comes with a JRE. So use only JRE as a base image, unless you're still going the JSP route, which requires a compiler at the runtime to convert into servlet and then do all the magic. So if you're using just a JRE, just minimize your Docker image. Use JRE as a base image. So here what I'm doing is, I'm using JDK 8 as the base image, Maven 3.5. So using that, I can compile the application. Then I'm saying from the build stage, copy the target directory here locally, set up this as a target directory and fire up my application. That's it. So now all the gobbledygook that was done in the first phase, classes, Maven repository, everything is left behind. And all I care about is my war file and my JRE, and then fire it up. So that way my image stays lean. So it's very important to understand that you're using JRE as a lean image. Now, the other option that I also talked about, this is JDK 8, of course. With JDK 11, you don't ship a JRE because the idea is it comes with tools like JLink. And it's all modularized. So you can say, hey, you know what? Here is my application. Tell me what modules it depends upon. So let's look at that actually. I'll get back to Jib in a second. But Now I'm copying my var file to a jar file because this tool called as JLink only operates on jar files. So that's one step. Second is I'm using two tools called as JLink and JDeps. Now JDeps, what it does is it takes a look at my jar file and it says, tell me all the dependent modules from the JDK 11 side. It gives me the list of dependent modules. And then you can see a list of modules. That is what Spring Boot requires. So what I've done is essentially I've taken my list of modules, used JLink to create a custom JRE for me. And the advantage that you see, and by the way, let's look at the Docker file once I have my custom JRE created. So if we want to look at my Docker file JRE here, very simple. All I'm using is a Debian 9 Slim because I have my JRE already ready for me. So I just copy the app var, copy the JRE, set up all my ports, and then I say, use my custom JRE and fire it up. In one case, I was using multi-stage Docker file. In this case, I'm using your single Docker file, but using a custom JRE. What is the advantage? If you go down, actually, a huge advantage. That is in terms of the size here. With the two-stage Docker file, my Docker image was about 490 megabytes. With a custom JRE, it's about 160 megabytes. It's literally 1/3 the size. And I can actually tweak it down further. I gave a talk last year at DockerCon, which talks about how do you optimize your Docker image, particularly from Java outside of the world. We can bring it down to really bare minimal, like, whatever is required by Spring Boot. And then I can start shrinking my application down to a few megabytes. So that's very powerful that you want to understand. So pay special attention to what your Docker image looks like, because with Java, the tendency is the image can bloat up rather quickly. But particularly in the microservices world, as I said earlier, because the image could be downloaded on a host, you don't want that to impact your performance. Now, one of the tools that I also want to talk about is Jib. So let's take a look at it. Let's go back to our POM XML for a second here. Now, Jib is a tool. It's a Maven plugin, essentially. It's a tool by the Google Container Tools team. And I really like it because it's a first-class experience that provides you in Maven. There are a lot of other Docker Maven plugin from a lot of other folks like Spotify and Red Hat and Fabricate and a bunch of other teams. But this has sort of, has got a good amount of traction in the developer community. And the idea here is that you don't need to write a Docker file. You are a Java developer. You know how to write Docker and Maven. You know how to write Maven files and Gradle files. Just embed that plugin in there. Just give your natural Maven statements and Gradle statements in there, and it'll take an opinionated approach to create your Docker image. No need to write a Docker file at all, as a matter of fact. So in this case, as you can see, I'm specifying what my base image needs to be, what my image name needs to be, what my environment needs to be, port, etc. I don't care about my Docker file syntax now. So now I can just say Maven package. And in this case, as we said earlier, this is actually in a profile, in a Jib profile. So by default, if I say Maven package, it will just generate my jar file. But if I say Maven package-p Jib, now it's going to generate my Docker file. So you can see how seamlessly it integrates with your Java development cycle. You want just a jar file or a jar file, and use that jar file to package up your Docker image as well. Either way, end of the day, what you get is a Docker file or a Docker image, okay? Now what you want to do is you want to run that file and get a feel for it, that when I run that image and I get a container, how do I test it? So let's try this. I'm going to copy this command here, and I'm going to paste it here, and I will run it. Oh, port is already occupied. I thought we canceled it already. Ooh, a lot of containers running. Let's remove all the containers. Let's try it once again. It's still having some port conflict. So I'm not going to debug into this. But the point being, if I run this now, And now, once I run it, so let me explain the command here. So what I'm doing here is, I'm saying docker container run, give it the container name greeting, do the port forward 8080 on the host to 8080 on the container, run it in a background mode, and this is my image name. So either way, multi-stage Docker file, single stage Docker file, jib, whatever plugin you're using, you get a Docker image. Now you want to run that image, and then what you want to do is you want to access the exact same URL and expect the exact same output. So in your Kubernetes journey, you have a Java application, you Dockerize it, you get the exact same output. That's sort of the end result that the customer expects, right? So you move on with that. Now, we talked about creating a minimal Docker image. Now, the next step is to get a feel for it. How do I, start on a Kubernetes journey of it? Docker is the first step here. Now, once you have the Docker image, then essentially the way Kubernetes, how many of you are using Kubernetes in some shape and form today? About 30%. So let me kind of give you a quick background of Kubernetes. Now, why is Kubernetes required? Think about it. You have a Docker image, okay? When you're building a Docker application, when you're building an application and you're containerizing it, then each component of the application is essentially a Docker container, okay? If you're building a microservices-based application and potentially you have lots of containers running around it, it's okay during the development time when you're running Docker for Mac or Docker desktop, then scaling up those containers and playing around with 1 or 2 instances of those on your machine. But once the application goes into production, then you have lots of those containers, potentially hundreds and thousands of those containers spread across a variety of hosts, lots of hosts, okay, hundreds of hosts. You need somebody to manage that cluster, and then you need somebody to be able to place the container on the right host, meeting your requirements of the application. That's a cluster manager and a container orchestrator. So there are lots of those available. Amazon has a service called as ECS that we offer. But then you of course have Kubernetes, which is an open source container orchestrator and scheduler that has those components baked in. So that's the role that Kubernetes really plays in. Now the language that Kubernetes talks is, it understands Docker image, but it has this concept of a Kubernetes manifest. So there are different Kubernetes resources. And the lowest resource that Kubernetes understands is called as a pod. And pod is nothing but a group of containers bundled up together in a manifest file. Manifest file is nothing but a JSON or a YAML file in which you display what the pod is going to look like. You put the metadata about the pod, you talk about the ports that are going to be exposed, etc. Now, don't think of pod as your application. Think of pod as an abstraction above the container, where typically in a pod you will have a single container, but there are lots of use cases where you will have a sidecar container in addition to your application container where it would sit above. So think about if your application is a simple order application, and the order application has, let's say, a database, a middle tier and a front tier, typical classical 3-tier application, or maybe just a front-end tier, a REST backend, and a database, okay, something like that. Those 3 are essentially 3 different parts. So from a Kubernetes perspective, what you're looking at it is, now I need to write a Kubernetes application, and in that Kubernetes application, I need to write these 3 manifests, and each manifest will have a pod. Okay, so you need to understand a little bit of how to write that manifest file. But once you've written the manifest file, so that's your journey from Docker image container to a Kubernetes pod. Okay, so you need to write that pod by yourself. But once you have written the manifest, then your goal is to understand, okay, I want to test this application on my local machine. How do I test it? Lots of different options for that as well. There is Minikube, of course. Minikube is nothing but a VM environment in which you can run Kubernetes as a single node cluster on your local machine. That's quite popular. My favorite is Docker Desktop, because as I'm building the Docker images, I'm very likely to have Docker here on my machine. And because I have Docker, so what I can do is I can look at sort of the Docker preferences here. And in the Docker preferences, for example, I can see there is a Kubernetes tab here, and I can enable Kubernetes. So in Docker Desktop, I can simply turn on Kubernetes. That really allows me to have a single node Kubernetes cluster running on my local machine. So as I'm making the journey, all of this is happening on my local desktop. And once you click on this, you apply it, download the Docker images that are needed to get your Kubernetes cluster up and running. And once Kubernetes cluster up and running, so now you can say, kubectl, show me the different contexts that are available. So what is kubectl? Now, imagine you have Kubernetes cluster created, one on the local desktop, one in the cloud, one somewhere else. So kubectl is the CLI on how you interact with those clusters. So on your local desktop, you have the configuration stored, the authentication data, the cluster name, the cluster server address, and all those things. But then at a given point of time, you can point your kubectl to one of those contexts and say, go talk to that cluster. What that means is now, remember the manifest that we created earlier? It will take that manifest and then you'll say kubectl, apply that manifest to the cluster. Which cluster? The one that is currently configured. So if I go here for a second, I can say kubectl, well, let's clear it first. Kubectl config get context. I got a lot of clusters created over here. So there is a EKS cluster that is using GPU, another Kubernetes cluster, another cluster that shows Kara integration, but I got a lot of clusters created over here. So at a given point of time, I can point to a cluster and then my commands are applied to that cluster. So for example, I can say Docker desktop or Docker for desktop, and I can say kubectl config use context Docker for desktop. And over here, if you see, the star is to Arun at EKS GPU cluster. Now if I get the context, now the star comes to Docker for desktop cluster. And what that means is now my kubectl commands are going to be redirected to my local cluster on my machine. So once I've created a cluster, then what I need to do is I need to deploy that application to the cluster. Now, remember we talked about the concept of my application consists of multiple microservices, and each microservice is essentially nothing but a pod spec. And there are multiple ways by which you can create pod spec, but how do I coordinate the creation of all of those pods together? How do I give it a meaning of an application? And that's where the concept of Helm chart comes in. Okay. Now there are other concepts that are getting prevalent in the industry called as CNAB, or Common Network Application Bundle, which is sort of a layer above Helm, but we're not going to get there. Helm chart is very prevalent in the industry, so let's look at that for a second. So Helm is nothing but a Kubernetes package manager, and what you can do is it's basically a directory with a templates directory in there. You can put all of your pod specs together in there, and it gives you a templating mechanism. By that templating mechanism, you can start leveraging that. Oh, I want to have a certain naming scheme to all my pods. I want to have a certain port exposed to all the pods. I want to have a certain metadata attached to all the pods. So you can start templatizing all of that information, particularly when you're using a Helm chart there. Okay. So let me show you the Helm chart for our application here. So if I go to the manifest directory here, I can look at the my app. Now this is my Helm chart. Okay. Now, of course, there's a top level chart.yaml, which talks about what is this application, version, etc. But if I go to the values.yaml, that's where my constants, so to say, in the chart are defined. And then, so for example, in the values.yaml, you can see my image name, my replica count, how many instances, how many replicas of the pod I want to run. Now, if I go to the templates, that's where sort of my greeting deployment, which is where my pod spec is defined essentially. So if I look at it here, now I'm saying, here is my API version, here is my kind, here is the metadata that I'm going to assign, here are the labels that I'm going to assign to the pod. Now I'm saying values.replica count. So I want a single replica of this pod. Then I'm adding more metadata to the pod. And then I'm defining the pod spec. that this is how my pod is going to look like. So once you understand this language, then you can create, in my application, I have a single deployment or a pod, but in your application, you could have multiple of these files in the template directory here, okay? So once you have done that, then essentially what you're saying is my Kubernetes cluster is ready using Docker for desktop. Then I have installed, at least today with Helm 2, there is a client component and a server component that needs to sit in your Kubernetes cluster. So using kubectl, you configure Helm in your server, and then you're saying, okay, now I'm going to take my Helm chart and deploy it into the Kubernetes cluster. So then what Helm is going to do is going to read through all of these templates. So for example, in this case, it's going to take a deployment, going to take the service, deploy it into the Kubernetes cluster, and have my application up and running. Let me talk a little bit about why the concept of service is required here. Now, think about in a classical stateless application, what happens? The whole concept of pod is it's a stateless container. And what I mean by that is it's a greeting container, for example, in our case, and there is no state maintained in the container. Every time I ping /hello, I get the same response back. Or I may be passing a parameter, then it may read into the database and get the results back to me. It doesn't matter if I have 5 replicas of the pod running, I can call any pod and they will all give me the same answer back. There is no state in the pod itself. Now, the whole value premise of Kubernetes is you can fire up 5 replicas of the pod, and Kubernetes will make sure that that many replicas of the pod are maintained at a given point of time. And what that means is if a pod goes down, Kubernetes will bring it up on a different node or maybe the same node, and they have an algorithm for that. So the point being the pod is an ephemeral. And what that means is, let's say you have a backend pod, you're running a bunch of wildfly swarms over there. That is your backend pod. What that means is from the front end, you can't really connect to a pod as an IP address. So pod being ephemeral, you need something that is more referenceable. And that's what service provides. Service is basically a logical name. And all it does is service says, I am going to include any pod that has a particular label on the pod. So if we look here, for example, if I look at the greeting service, I have other metadata here, but then in the selector, I'm saying any pod that has release name -greeting on the pod is going to be part of my service. If I go back here, voila, here we have release name -greeting attached to the pod. That means this pod, the 5 replicas of the pod come up, the service comes up, it says, yep, you got all these labels, you're part of my service. From a user perspective, now you can attach to the service, and service will do sort of a L4 load balancing for you across those pods very easily. That's the key part, okay? So usually you will have a deployment that will create a pod and a service that will front end that deployment so that you have a referenceable endpoint for it. So that's sort of a bare minimal Helm chart that you would typically create. So now if I go back to my application here, I have installed Helm in my Kubernetes cluster. I have a Helm chart. I deploy my Helm chart to the Kubernetes cluster. What is it that I want? Now I want to access my application. I want to see my hello response back because that's sort of my customer contract here, okay? So how does that work? Now, look a little bit deeper here. So if I go back to my greeting service, here I'm saying type : load balancer. That's one of the attributes of service. And what that means is wherever this service is deployed, if it's deployed in the cloud, then look at the corresponding cloud's load balancer. So if it's deployed on AWS cloud, for example, provision a ELB for me, Elastic Load Balancer. If it's deployed on a local machine, make the service accessible to me on localhost. Okay, so that makes it easy. So now I can at least start accessing my service. So if I go here, all I'm doing is, hey curl, HTTP, let's dig into this a little bit. Okay, this is a command over here. And then I'm saying 8080/hello because the service is exposed on the port 8080. So what I'm doing here is, I'm saying kubectl, let me make it a little bit bigger. I'm saying kubectl, get me the service, and my service name is my app/greeting. And I'm saying, give me the JSON path, which is status load balancer ingress port and hostname. And that basically would give me either localhost if I'm running it on the local machine, or it would give me the ELB name if it's running on the cloud provider. So independent of where my service is provisioned, I'm getting the host name where the service is now accessible, port, and the URI, and I'm getting the response back. So that's the important part. So think about the journey again. Spring Boot application running in a terminal using Maven plugin. Then next step is Docker, running as a Docker container, getting the same result as hello. And the third step is really setting up your Kubernetes Helm chart and firing it up as an application and getting the exact same result. So that's your third step in the journey. Now, a common question is, as a Java developer, we are used to Java tools like, IntelliJ, NetBeans, Eclipse, whatever your favorite IDE is. So how do I debug my application? So let's go back to my Docker file for that for a second. In my Docker file, I have this environment called as Java options, okay? And I get these Java options, like in IntelliJ, for example, I can say, I wanna connect to a remote VM, and then it says, hey, just drop these options in your, somewhere where your JVM is accessible. So I copy these options, set up as Java underscore options as the environment variable. And now what happens is I fire up this application, and anytime I fire up IntelliJ, I can say, go connect to a remote VM using these parameters, particularly port 5005, which is mentioned over here. I'm connected to this VM now. Now, this could be running on my local machine. This could be running on a remote Kubernetes cluster. And I have the ability to start debugging my application, okay? So the huge advantage of this is, if you're building your Java application, it may behave all right, but more often it does not behave all right. So how do I start debugging that application? You bring your familiar tools, and now you're debugging a Kubernetes container, live in production itself. So that's the advantage I wanted to highlight over there. So if I go back here, so what we're doing is IntelliJ run debug remote, and it fires up, add these options essentially for your _Java options. And once I do that, then it kind of brings up, you set up a breakpoint in your application. And anytime, you invoke the application, same URL, but then it basically shows the breakpoint hit in IntelliJ. And now I can look at my entire stack trace. The class has no fields, of course, so it doesn't show anything. But if there is anything meaningful, interesting data, it kind of spits out your entire stack trace and your class state over there. And the same thing, of course, works for when you're running it as a Docker container as well. Now, your application is looking good, so you understand how the debugging of a Java application in the Kubernetes land works. Your next step is, all right, I've done testing on my local cluster. I want to move it to a cluster in the cloud, a Kubernetes cluster in the cloud. Lots of different options for that as well. But per the last CNCF survey, 50% of Kubernetes, more than 50% of Kubernetes runs on AWS. So and I work for AWS, so my preferred choice is Amazon EKS. Now, Amazon EKS is what it gives you is a managed Kubernetes control plane on the cloud. So you go to AWS console, choose EKS, it creates a Kubernetes cluster for you. You bring your worker nodes, attach it to the Kubernetes control plane, and voila, you got a fully managed Kubernetes cluster over there. Okay. Well, that's one way. Or Weaveworks is a great partner of AWS, and they created this open source API called as EKS Cuddle, very much like kubectl. Is EKS Cuddle. So literally, you brew install the API, and with a single command, you can say EKS Cuddle create cluster, specify the region and the number of nodes that you want, and that's it. If you give that single command, it builds the entire EKS cluster for you. It uses CloudFormation at the back end and all that magic, but end of the day, in a few minutes, you basically get your EKS cluster ready to go. And if you go back to my terminal here for a second, all the clusters that I've created using EKS, they actually have this kind of a namespace and or the context or the context name basically. So in this case, I'm saying I've created a GPU cluster, so I call it as EKS GPU. So now if I can go back here, use context, I can pick this name instead, and I can configure to that. So something like kubectl, I can say, show me the nodes in this cluster. is saying it has only 2 nodes. Well, these are GPU nodes. These are P3 8XL. So these are pretty heavy nodes. And I created this cluster yesterday. So you can say, the status is ready. There are no roles assigned to it. And it's a day old cluster. And it also gives you the version number of the Kubernetes that is being used over here. Now, if I were to go back to say Docker for desktop, I switch the context over there. And now I say get nodes. Then of course it's a single node cluster, which is running on my local machine. So that brings your story. How do you migrate your application from desktop to the cloud? Well, you run your exact application on the desktop, using Docker for desktop, Minikube, whatever works for you in your favor. Then once you have done that, then you literally switch the context. Say, hey, kubeconfig or kubekernel, I'm gonna now point to this cluster running in the cloud and just redeploy your application. The big advantage of that is because you're using the same manifest files, you're using the same Docker images, there is very little impedance mismatch. Now, does that mean you have to use the same environments? You don't have to. You can start customizing it. A lot of customers do that where, this is my testing database and my testing app, and there are slight tweaks required when I go to production and I have the environment variables that override this. And that's totally all right. But the point being, literally migrating to the cloud in terms of from running your application on the local desktop to like a EKS cluster, just switch the context and redeploy the application. So literally fire the same command again. So in this repo, I would highly recommend to mark this repo because that's where all the work happens. But basically here it explains how do you switch the context. Now there are commands that are required to install Helm in the EKS cluster, and I highlight those part of it. But then all you're doing is Helm install, deploy the same application in the EKS cluster, up and running very quickly, okay? And now once I have once I have installed Helm in my cluster, then I can say kubekernel get service. So let's actually go back here for a second. Kubekernel get service. I don't have this thing installed here. I don't have the greeting application deployed over here, but what we can do is we can very easily deploy sort of my local application here. So if I go here, I go to the manifest directory, and if you remember, my app was the directory where my chart, templates, everything is specified. I have my greeting service and greeting deployment over here. So now I can just take this command. Oh, wrong one. So if I take it this way, Helm install like this, okay? So if I go here, I can say Helm install -- name my app manifest / my app. If I give this command, I need to Helm init as well. So this is now installing basically Helm into my cluster that is currently configured by kubekernel. So this is the local cluster. So now it's deploying Helm into the cluster. Remember I said Helm has a client component and a server component. So it's installing the client component is already installed. It's installing the server component in the cluster. And once it's installed, then I can say Helm install name my app. And here it deploys my application. Now I can say kubekernel get service, deployment, and pods. So it's saying, all right, service is here, load balancer, and because you're deploying on a local machine, it's localhost. And here's my deployment, 1 out of 1 is ready, and here is my container or pod. This particular pod has 1 container and 1 out of 1 is ready. So now if I were to switch the context to say this GPU cluster, I can switch the cluster and essentially same set of commands. Now I'm just saying Helm init. Now Helm init is now deploying Helm server component on the GPU cluster over there. It takes a while for the daemon set, which is basically one instance of Helm running on each node to come up. But once it comes up, then all I do is exact same command, Helm install. and this is going to install my application, the same application now on an EKS cluster. Oh, I need to install Helm a bit differently actually on a EKS cluster, right? It's configured as a service role. So, but once I configure that, then the same command would work over there, and then I can start getting the exact same command. Now, one of the things I want to talk about is, all right, cool. Now you have your application deployed over there. Now you want to do things like canary testing. I have a new version of the application and I want to put it into the cluster. And I want to only give it to 5% of the customers. And I want to see how the application behaves. And based upon how the application behaves, I may want to scale up or back off the change. Now, how scale up and scale down works in a traditional world, in a traditional Kubernetes world. Well, you have a deployment. In a deployment, you can say, here are the number of replicas that I want for the pod, 4, 5, 10, whatever it is, okay? Now, you want to introduce a new version of the application and you want to give it to only 5%. So think about this. Now, you are having 5 replicas of a pod. What is 5% of 5 in a whole number? Well, the closest number is 1, and that 1 is 20%. So what that means is, in order to give 5% traffic only to the new application, you really have to scale this one up to 20, so that then you can give this to one pod. So essentially you will have 2 deployments running. One is the existing deployment and one is a new deployment. So you run both of those deployments. Both of those deployments have exact same set of labels, a little bit different, so that the service picks them up, okay? Now, if you do 5 of existing and 1 of new, that's 6. And the service is going to round robin between those, but that's not 5%. So in order to give 5% to this new one, you will have to really scale it up to say 19, and then this becomes 1, and that is 20. So then if it's round robin, then it's 5% traffic. So unnecessarily, you have to scale your application over there. So Kubernetes by itself does not have the capability by which you can start diverting traffic to only 5% of the users. That's where components like service meshes come in play. So what is service mesh? Service mesh is essentially, think about your application running on the data plane, okay, which is basically the EC2 instances, lots of pods, and each pod have a single container in it. So what service mesh gives you is service mesh is basically taking Envoy, which was a project built at Lyft, and inject this as a sidecar container in each of the pod. All the network traffic across the services does not happen directly between the pods. Because the sidecar container is living in the same pod, anytime an application container wants to talk to a different application container, it talks to the sidecar. Then sidecar has the policy configured on which applications are allowed to talk or not allowed to talk. And then it talks to the other sidecar, which then talks to the local container. And that's how the communication happens. So all the network traffic basically happens through the sidecar. Now, think about your application running hundreds of microservices with thousands of containers running across. So thousands of application containers means thousands of sidecar containers. So think of that as a service mesh data plane. You need something on top of it as a service mesh control plane, which can tell these data plane pods or containers which service is allowed to talk to which service. Now, how much traffic you should be getting and things like that. So that service mesh data control plane is basically Istio. Istio is one of the options. Of course, AWS has a managed service around that as well. We call it as app mesh. So those are 2 prominent options that we are looking at it from the AWS perspective. But the idea being, service mesh is very powerful and it really allows you to manage those application concerns that are not easily available in the Kubernetes land itself. I won't dig into the details of service mesh by itself, but you can look at the instructions over here, how service mesh or Istio particularly can be installed as a Helm chart here. Once the Helm chart is installed, how you can do traffic shifting. That, okay, I'm introducing a new version of the application here. I'm deleting the app and I have an app hello howdy. Okay, so let's look at that app hello howdy. Now in this case, I have a greeting hello, which is using Arun Gupta /greeting:hello. And then I have a greeting howdy, which is using Arun Gupta / greeting:\howdy. Now, if you see the difference between the two, they both have app:\greeting as a label and app:\greeting as a label. The different label is greeting:\howdy and greeting:\hello. If I look at the corresponding service says I only want app:\greeting. So the way it works out is service pulls in both of these pods. Because you have Istio enabled in your cluster, you need to create additional resources. So for example, in this case, I can create an app rule, and these are basically Istio resources. So I'm creating a virtual service here. And in the virtual service, I have two destinations. One is greeting:\hello and one is greeting:\howdy. And in this case, I'm saying 75% of the traffic goes to hello, 25% goes to howdy. And if I go down here, how do I define those subsets? Using the remaining labels on the pod. So service picks up both of them, but then on top of that, I define a virtual service which kind of splits up the traffic 75%, 25%. So I can be a lot more granular in terms of what Istio allows me to do. So now that's one common feature of Istio. There are a lot of other fun things that you can do: canary deployment, distributed tracing, and all sorts of fun stuff. So I won't go into the details, but let's kind of recap our journey. Well, one of the things I didn't get to talk about today is how you can easily do deployment pipelines. There are tools available. There is, of course, well, let's talk about 15 seconds on this. There are tools available like Scaffold that can allow you to build deployment pipeline locally on your machine. There are tools like JenkinsX, which provides first-class native experience on building your pipeline. If you are a Jenkins user, JenkinsX is a very logical choice for you. There are, of course, Code Pipeline, which are fully managed services by AWS that offers you in that realm. But the point being, let's recap our journey here. As a customer, if you build your Java application, the first step is to Dockerize your application, create a Docker image. Second step is write that Kubernetes manifest. Third step is to kind of take a look at it, how you can test that application locally on your desktop. Fourth step is, okay, now I'm going to migrate that application to the cloud. Then the next step is, all right, if I need to debug it, test it. And then finally, if you're looking at it, maybe you want to install like a Istio or a service mesh to get more observability around your services. So I hope you find this useful. This is where the GitHub repo is. Take a look at it. Please file any issues. I'm going to be outside if you have any more questions. Thank you so much.